Before we look at the actual problem, let's look at what type of data can we get from our experiment. Well, first of all, for any substance that can dissolve in a solution, we can actually determine a calibration curve by measuring absorbances of different known concentration. So basically, we take different concentration of that substance and measure the absorbances. And that's the reason why we have concentration versus absorbance. So that's the basic thing that we can do with a spectrometer, okay? Now, why would we like to make a calibration curve? Because when we create a calibration curve, we have a slope. And what's so special about slope? Well, the slope of this line gives us A equal to B. Remember the Beer law is equal to A, B, C. Well, the slope is this part right here. And this can be measured directly using the spectrometer. Now the concentration, this is what we are going to solve. So by having the calibration curve, we can solve for this two variable, and this will be just directly from the spectrometer. Now we can finally solve for the concentration. Now let's look at an example problem where we can actually carry this experiment in our class. Well, to determine how many coppers in an old penny coin, the student dissolved a 2.0 grams penny in 25 milliliters of nitric acid overnight. Then the student diluted the solution to a volume of 100 milliliters. So what's happening there? So in this case, we have what? Let's draw this out. So this would be 25 milliliters of nitric acid. And this is your penny, okay? And the penny is going to dissolve, okay, overnight. Now what we're going to do next is that we're going to take that 25 milliliter, okay, and we're going to dilute into 100 milliliter. And now basically we have the solution where the copper is dissolved in nitric acid. So this 100 milliliter solution, which including the penny that's being dissolved, is the solution that we are going to work with now, okay? Let's continue. The student created a calibration curve, okay? Below this is the calibration curve, by measuring absorbances of different concentration of copper nitrate. Well, notice how copper, that's the same copper in the penny. And we can control the concentration of copper nitrate to whichever we want. And that's how we create this calibration curve. The student tested the solution made from 1 penny. This is the one that's being tested, okay? And found that the absorbance of the solution was 0.125 at the wavelength of 630 nanometer. Now this is not B, okay? This is not the same thing as B. That's completely different, so keep that in mind. B. This is not the width of the cuvette or the vial that hold the solution. So we need to keep that in mind. And that's why we need to look at the calibration curve, because the slope of the calibration curve will give us AB, which we don't know. And this one we don't know, but the slope will give us that. Absorbance is equal to AB times C. This right here is going to be our slope. Okay? And with that, we can now solve because we have the absorbance given us by the spectrometer. Okay? So let's find the slope. Well, to find the slope, we take 2 points, which is given to us, which is the change in y over the change in x. So we have 4.5 minus 1.5 divided by 5.0, okay? I'm going to put e to the negative 3 minus 1.0 e to the negative 3. And this gives us, what do we have? On top would be 3.0, on the bottom would be 4.0 e to the negative 3. And turn out to be, let's plug this into our calculator, 3.0 divided 4.0 e to the negative 3, and that turned out to be 750. And this 750 is equal to A times B. Okay, that is our slope right there. Now, let's look at the problem. What is the concentration of copper in the solution from 1 penny? So we know that A equal to ABC. Remember, this is our slope. So what we can do now, and this one right here is absorbance, which we know is 0.125. So this is equal to 0.125. So let's solve this. We have 0.125, okay, equal to slope. And what's the slope going to be? 750, right there. Time your C. See, this is our slope. So what is C is going to be? Is 0.125 divided by 750. And that turned out to be, let's plug this into our calculator. We have 1.67 e to the negative 4 molarity of copper 2 plus. And that is our answer. Now in this case, part 2, how many moles of copper are in the penny? Well, remember this right here? This is actually your number of moles over 1 liter of solution, okay? And if we rewrite this, this is actually equal to what? 1.67 e to the negative 4 mole of copper 2 plus over 1 liter of solution. And do we know how much of the solution we use? So let's use this as a conversion factor. So this can be used as a conversion factor, okay? And how much of the solution are we actually using? Are we testing in this case? 100 milliliter. And 100 milliliters is equal to how many liter? 0.1 liter. So now we know how much solution we use. Let's time this conversion factor. And in this case, the liter on the bottom, 1 liter of solution, and on top is 1.67 e to the negative 4 moles of copper 2 plus. Now we can solve for moles of copper 2 plus, which is 0.1 times 1.67 e to negative 4. It will be equal to, easy math, in this case 1.67 e to the negative 5 mole of Cu2 plus. There you go. And that would be the moles of coppers in the penny. Isn't that easy? Now, how many grams of copper in the penny? If you have moles of coppers, just convert it by, multiplied by the molar mass. So in this case, 1.67 e to the negative 5 moles of copper 2 plus times the molar mass. What's the molar mass of copper? Look at your periodic table. The periodic table, and we found that the molar mass of copper is 63.54. So we have 1 moles of copper 2 plus on the bottom, and the gram would be on top. 63.54 grams of copper 2 plus. The mole cancel out, and if we plug this into our calculator, we have 1.06 e to the negative 3 grams of Cu2 plus. And that would be the mass of copper in grams right there. And lastly, what is the percentage of copper present in the penny? Well, remember, percentage is what? Percentage equal to, all percentage were equal to part divided by total times 100. In this case, what is the part? The part is right there. What's the total? What's the total mass of the penny? In this case, the mass of the penny is 2 grams right there. So what we have here is equal to 1.06 e to the negative 3 grams of copper 2 plus divided by the 2.0 grams of penny. That would be the total mass, okay? In this case, we multiply by 100, and what do we get in the end? We have 5.30 e to the negative 2%, or in terms of decimal is 0.053% of the penny will be copper. So this right here, a basic stoichiometry, okay? But in order to understand, or in order to solve this problem, you need to realize that the calibration curve gives us the slope, which is equal to A times B.